All right, let's break down one of the most important stories of our time, the science behind our changing climate. What's really happening to our planet, and more importantly, what's driving it? We're going to dig into the evidence.
When you see a picture like this, have you ever just stopped and wondered what makes our planet so special? Why is Earth this vibrant, living world just teeming with life, while all our cosmic neighbors are, well, silent and barren? The answer, it turns out, is all about its climate.
Okay, so let's dive into that. It all starts with Earth's climate system. The best way to think about it is like a massive, incredibly complex engine that powers all life on the planet. And this engine, it's always running. It works through this huge network of currents in our atmosphere and in our oceans, and their main job is to move heat and moisture all around the globe. This amazing distribution system is exactly why you can have a lush, green rainforest in one part of the world and a dry, arid desert in another. Every single living thing has adapted to and depends on these very finely balanced climates. So, what is it that keeps the planet's temperature in that perfect, just right zone for all this life to flourish? Well, the key is a completely natural phenomenon, the planet's very own greenhouse. And here's the most important thing to get right off the bat. The greenhouse effect is a natural and absolutely essential process. It's not inherently a bad thing. Think of it like a natural insulating blanket made of gas that wraps around our planet and it traps just the right amount of the sun's heat to make life possible. Here's how it works, and it's pretty simple. High-energy sunlight passes right through the atmosphere and warms up the Earth's surface. The planet then radiates that energy back out, but as lower-energy heat. Now, instead of all that heat just escaping into space, some of it gets absorbed and bounced back by the gases in that blanket. The result is simple, right? Sunlight comes in, and some of the heat stays. So, what is this atmospheric blanket actually made of? Well, the main heat-trapping gases are things you've probably heard of: water vapor, carbon dioxide, methane, nitrous oxide, and ozone. And get this, even though they make up just a tiny, tiny fraction of our atmosphere, their combined effect is powerful enough to regulate the temperature of the entire planet. And to really drive home just how vital this is, without this natural greenhouse effect, the average temperature on Earth would be a frigid 0 degrees Fahrenheit, or minus 18 Celsius. It would be a frozen, completely lifeless rock. Okay, so we've established the greenhouse effect is natural, it's necessary, it's a good thing. But that leads to the big question, right? If the climate has its own natural rhythms, what's so different about what's happening now? And it's true, the climate has never been static. Over millions of years, natural forces like subtle shifts in Earth's orbit or massive volcanic eruptions have caused the planet to warm up and cool down in these long, very slow cycles. Which leads us to the critical question. If change is a natural part of the system, then what in the world is causing the incredibly fast, incredibly dramatic shift that we are all witnessing right now, in our lifetimes? Believe it or not, the answer is literally frozen in time. Scientists can drill deep, deep into the ice sheets in places like Antarctica and Greenland, and they pull up these things called ice cores. Inside the ice are tiny little air bubbles that got trapped, sometimes hundreds of thousands of years ago. They're like perfect little time capsules of Earth's ancient atmosphere. And this is the story these ice cores tell. This graph shows CO2 levels in the atmosphere going back 800,000 years. You can see it, right? The natural rhythm, the ups and downs between ice ages. It's all there. But then, look all the way to the right. See that nearly vertical line? That sudden, massive, off-the-chart spike? That's us. That's today. Let's put some hard numbers on that spike. For almost a million years, CO2 levels naturally bounce between about 180 and 300 parts per million. As of 2019, that level was 411, and it's still climbing. We're way, way outside the natural range that our planet has operated in for a very, very long time. So what caused that crazy, unprecedented spike? Well, all the evidence points directly at our collective fossil fuel footprint. The story really kicks off during the Industrial Revolution. That's when we started burning massive amounts of coal to power our factories and build our cities. And that initial reliance has just exploded into what you could call our modern carbon culture, where pretty much everything, from the lights in our homes to the cars we drive, runs on burning fossil fuels like coal, oil, and natural gas. And all that burning releases that ancient carbon back into the air. But it's not just what we're putting into the atmosphere, it's also what we're taking away. You see, forests are like giant sponges for carbon, but when those forests are cleared and burned, all of that carbon they've stored for decades or centuries is released right back into the atmosphere as CO2. And just to give you a sense of the sheer scale of this, every single year, an area of the Amazon rainforest that's equivalent to 1 million soccer fields is cleared. 1 million. It's a staggering loss. So let's bring this all together and look at the most direct modern-day evidence of our impact. Because when you see it, the trend is just unmistakable. This right here is the famous Keeling curve. It's a continuous measurement of CO2 in the atmosphere that started way back in 1958. That little annual zigzag you see, that's literally the planet breathing. It's the vast forests in the northern hemisphere taking in CO2 in the spring and summer and releasing it in the fall and winter. But the most important part of this graph is the overall trend, that relentless, undeniable upward climb. It's the clear signature of human emissions. So the data very clearly shows us where we've been and exactly what's happened. It gives us that scientific bedrock for understanding our changing climate, which leaves us all with the ultimate question. Knowing what we know, where do we go from here?